Welcome to today's masterclass. My name is Jose Rivera, and I am the CEO of CSIA. In case you don't know about CSIA, we are a global nonprofit trade association with over 500 members in 35 countries. For system integration members, the CSIA Best Practices Manual and CSIA certification are some of the more popular member benefits, but they also enjoy a variety of others, including professional development, learning from their peers, and access to professional service experts, including insurance, financial, and legal, who understand the system integration unique business needs. For partner members, CSIA offers an ecosystem to grow their system integration program, understand their customers' pain points, monitor industry trends, and share their thought leadership. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange will help system integrators, industry suppliers, and manufacturers connect and do business. For SIs and partners, it provides a platform to support your content and SEO marketing efforts. Position yourself as a thought leader and nurture prospects during the complicated buyer's journey. The good news is that we're now halfway through the year, and both membership dues and exchange profile updates are prorated, which is just a fancy way to say that they are half off. We have put together a first-timer package for companies that join in July and August that includes some new member benefits, including an EPUB of new products and services called Innovation for Integration. The package includes a free listing in this EPUB, but also some other goodies to help you get your message and brand in front of your customers. Get the details at www.controlsys.org/shine. At this time, I would like to introduce today's speakers, Brian Curtis and Robert Willis. Gentlemen.
Brian, you're muted.
Yes, Sandra, thank you. I did lose my connection for a second here. Am I up?
No, you need to share the screen.
Okay.
Perfect.
Can we see my screen okay?
Yes, sir.
Okay, very good. Well, thank you for joining us today. I'm Brian Curtis, and I'm an automation system and architecture expert here at Schneider Electric, and I'm well-versed in industrial automation architecture and SCADA systems. Please feel free to use the Q&A feature in Zoom today. There will be members of our team there to answer your questions. Today, we're focusing on the integration of our Modicon controllers and AVEVA system platform to give us an integrated control system. We know that customers are addressing certain challenges, including optimizing their CapEx and making their projects more efficient. We want to make sure we can shorten the delivery time and control their costs. Another one is the need to reduce their OpEx cost and improving plant performance and ensuring consistency across the control system, and then helping them adapt rapidly to changes. The more integrated we make our control system, the less work they need to do and the lower risk it is to make changes in the control system. Let's first look at these two systems side by side. Today, we have our process automation controller programming software, EcoStruxure Control Expert on our left, and we have our supervisory system, AVEVA system platform on our right. The implementation of these two systems required the creation of assets in both Control Expert and AVEVA system platform and the related communications to link the objects together at the supervisory level. The burdensome process of linking supervisory objects to the corresponding variables of the controller can be prone to mistakes that are discovered only in the late stages of the product life cycle. This approach can increase both costs and risks. To help with these challenges, we've significantly improved the integration of the control system when using Modicon hardware, and a Viva system platform. The first issue identified was our communication driver. We had to install our communication driver and then configure the driver correctly to each controller. We then had to go into the system platform management console and configure the OI server, the gateway, and associated
Brian, I think we have an issue with your connection. I cannot hear you. So I think Brian is trying to reconnect. Thank you for your patience. Robert, I'm going to make the following suggestion. You have your presentation. No, here's Brian. Brian, you're mute. You're on mute, Brian.
Can you hear me okay?
Yes.
Did I drop off for a minute?
Yes, you did.
Okay. Apologize for the technical difficulties. Do you see my screen?
Not yet.
Okay, let me share it again. Are we good?
Not yet. Here we go. But I don't think this is the presentation. This is look like your drive directory.
Should be looking at the system management console of the Modicon communication server.
Okay, then that's it.
Okay, very good. So the Modicon communication server manages the secured communication configuration between the Modicon controllers and a Viva system platform. The server embeds the capabilities of EcoStruxure OPC server expert to make all the variables selected for the HMI available within the supervisory system. The Modicon communication server ensures that the only information you need to configure is the IP address of the controller and the network admin password. Customers wanted an easier way of configuring their driver and removing the complexity of configuring the communications. To minimize the learning curve, we have built the engineering into the system management console, along with all the communications, configuration, operation, security, and diagnostics for a Viva system platform, and simplified the configuration in a single location. You can right-click on the Modicon communication server where you can start, stop, or restart the server. We can also migrate our OFS or OPC factory server configurations directly into the Modicon communication server. We've asked hardware questions, which enables the Modicon communication server to automatically select high performance settings as defaults for communication. And we've also leveraged the same parameter sets in diagnostics as OFS to leverage the existing expertise of our integrators and end users. We've configured both ends of the communication links to automatically complete and align the cybersecurity settings. The Modicon communication server configures the OI server, the cyber secure link, and optimizes the communications all in an integrated common environment. In summary, we automatically configure all the components you need to begin communicating to your Modicon controller. You simply create the controller with its associated IP address and provide the password for the network admin account, and the communication link is secured and configured. Device diagnostics allow us to verify our communication status and verify the quality of our data. The Modicon communication server is designed to improve the user experience and make it very easy to manage and maintain communications between the controller and a Viva system platform. The Modicon communication server simplifies the communication connection and provides data access to the variable name and the controller, eliminating the need to use an address or located variable. The Modicon communication server is fully supported by Schneider Electric and has a roadmap with continued enhancements, features, and capabilities. The second issue identified was independent configuration of the Modicon controller and a Viva system platform. We developed a tool that would allow us to take the configuration of the PLC and automatically generate the configuration and system platform, thus removing the duplication of work. We introduced EcoStruxure Control Expert Asset Link, which is a tool to convert a control project from the Modicon Process Automation Controller environment to an Aviva system platform project. EcoStruxure Control Expert Asset Link enables engineers to create a fully integrated control system to reduce design and commissioning time and deliver long-term system consistency. It integrates systems built with EcoStruxure Control Expert or EcoStruxure Machine Expert or Remote Connect for the SCADA PAC RTU, which are supervised by a Viva system platform. EcoStruxure Control Expert Asset Link analyzes our control project and reads the configuration information, including our function blocks, our data structures and associated variables, and our metadata and comments and initial values. Now, anything I configure in the controller no longer needs to be reconfigured in system platform. Making a change once is easy, but duplicating that effort in the supervisory system increases engineering time and risk. In the demonstration project today, I have a variable frequency drive object and a pump object from our general purpose library. For this VFD object, note the variable name P1001 underscore ATV 6XX underscore ATV underscore ST and its associated drive data type, which is ATV 6XX underscore ST underscore DDT. This will be the basis of our demonstration using Asset Link today. Asset Link automates the creation and updating of the application based on the data extracted from the expert project and removes the duplicate engineering effort between the controller and supervisory system by delivering mechanisms that facilitate the reuse of information already available in the expert project. The engineering of the supervisory application has the benefit of reduced errors, cost, and delivery time. Asset Link is delivered as a system platform template. We first open up Asset Link and we need to configure the environment. We first start with the source. We define the source. We can use Control Expert, Machine Expert, Process Expert, or the SCADA PAC RTU. We then define the protocol, the OPC UA protocol, the OPC DA protocol, or the OPC UA embedded communication module for the M580. We then define the device. The device, if you remember, is the PLC in our controller. In this example, our device is DEV example underscore 1. And we also define the DI object name or the OPC client and the associated scan group, which are configured in the Galaxy as part of the client. And we also need to identify the OI address reference. All of this configuration helps us to build the entire variable reference or namespace following the format below. We also define a pattern path, which we'll talk about patterns in just a minute. We have to define the path where these patterns reside. In addition, we point to the control project and its associated file. This configuration allows Asset Link to build the entire reference again for each attribute and dynamically links the asset in the supervisory system back to the controller. Asset Link uses pattern recognition to help us identify the asset in the controller. The pattern in the library has criteria that we use to validate the criteria and the asset, if you remember the names of the variables we just looked at. In addition, we define rules and actions that help us generate the new object or update an existing object in the galaxy with all the associated attributes. Rich data integration is possible as patterns are based as sample assets. Asset link patterns are generated by sample assets, which have names, descriptions, communications, comments, and initial values. Asset link can detect the reuse of any of these properties within the same assets and created rules to leverage the complete configuration of the controller. Asset link supports the use of multiple function blocks and data structures to form a single asset. Patterns can be maintained using version control for both major and minor revisions, providing greater flexibility to the user. Asset link supports Modicon libraries, including the general purpose library and custom libraries. The generation tab. Once you have the configuration completed and the associated pattern file for the object, you can then use the generation tab. When you browse the control project, Asset link will search the controller and identify the assets available. Asset link can create an object for or update an existing object. If you remember our sample project again, pump 1008, the VFD and the motor. Assuming I've created the VFD object in the controller, I would run asset link and it would identify the asset or assets and provide the option to create the object based upon the pattern in the library. Once the objects are created and deployed, they're ready to use end to end with their associated symbols and communications. Once I generate the object, you can see the complete associated attributes are linked back to the controller and the variable fields are automatically populated with the DI object name, the scan group, the OI address reference, the controller or device, and the variable and its associated attribute. Additional attributes are linked back to the controller automatically. The automation object is also linked to its associated symbol from the graphic toolbox. Once the object is generated and deployed, we can add the object in the graphic editor. The object is fully configured with its linked symbol end to end, including all the attributes and communications back to the controller. Asset link does not facilitate a one-time generation of objects. Instead, it serves the entire life cycle of an automation system. Asset link is easy to use, simplifies the integration of Schneider Electric controllers with the Viva system platform. Asset link is flexible and allows the use of your own standard assets. Asset link reduces engineering time, maintains consistency, reduces time to market, and lowers cost. This demonstration only integrates a single object. Imagine a system with hundreds of objects and the benefits of automating this process. Asset link isn't a custom tool, but has continuous involvement and support from Schneider Electric. Combine the libraries for EcoStruxure Control Expert, the Modicon Communication Server, Asset Link, and the libraries for a Viva system platform, and we have a fully integrated control automation system that simplifies the maintenance and configuration of your control system, improves delivery time with faster design and implementation, simplifies system changes, supports a range of communication protocols, includes Modicon libraries that are delivered with predefined patterns, and supports custom libraries with automatic pattern generation. Both Asset Link, the Modicon Communication Server, and the GPL or General Purpose Libraries are available today via download at our Exchange website, a place where you can collaborate with other experts, access resources from Schneider Electric and other service providers, and download software solutions. We appreciate your time and hope you have a great day. If you have additional questions, please reach out to your local Schneider Electric distributor or Schneider Electric sales executive. Thank you for attending this session, and this concludes my presentation.
Robert, you're on mute.
See, can you see my screen now?
Before we were, now you're not sharing.
Okay, so let's try this again. There we go. Should be up.
Yes, thank you. Perfect.
Good morning, everybody. My name's Robert Willis. I am Brian Curtis's coworker in the Houston, Texas area. I'm one of the automation system and architect experts, been working for the company 40 plus years. We're going to talk a little bit today about EcoStruxure control engineering and what it can do for you as a systems integrator that's needing to provide a completed solution to the customer, documented and verified against a set of rules that the customer may create for you. So we acquired a company called Interest Automation in 2019. They were a systems integrator created in 1995. In 2008, they changed their business model to be a software vendor. And in 2019, Schneider Electric acquired them. And their product used to be called Interest Automation. It's now called EcoStruxure control engineering. 20 years of R&D development, and what they did, they have experience in both the computer science and industrial automation world. So they took some of the engineering techniques that were commonly used in IT and embedded software with the aim of bringing them into the PLC programming world to provide a more disciplined, structured approach. So we're going to talk about a couple of the tools that they have available for you. And so what are some of the concerns today? The programs are getting increasingly complex, more demanding deadlines. You have to get the projects out quicker, have to get them out right the first time. Importance of security. Cybersecurity is a big issue today. Replacement of obsolescent systems. That's probably the big thing we're seeing today is how do we take a system that was put in 20, 30 years ago and migrate it to the new hardware and help you capture all the documentation that may have existed or understand the control flow and logic flow. Greater connectivity between different systems, and of course, lack of the experienced engineers that put the system in, you've got to re-engineer it. So how can we address these concerns? The proposal need a new software tool to assist you in automating that task, because the task really can't be efficiently carried out manually. The obstacle that you're going to be presented with is the proprietary nature of PLC, PACs, and the different abstraction of the IEC 61131-3 language as an example. And the solution is EcoStruxure Control Engineering Software Toolset. And it is a tool set. So the tool set comes in 4 different parts to it. The verification tool, automatic verification of conformity with a specific set of programming rules. The converter, we want to convert a legacy application from whatever vendor into Schneider Electric Modicon M580 as an example. Documentation, automatic documentation or generation of the documentation and workflow. And then also the last component is the monitoring. On the left-hand side, upper left, it supports all IEC 61131-3 languages. We import 2 defining features, the IEC language plus the PLC brand. And then we support major PLC formats. This will give you a bigger overview of it. We currently have over 40 languages from 11 brands, 20 PLC models currently supported. If you have one that's not on the list, please get with us. We're always doing development. As you can see, Schneider Electric, PLC Open, CodeAssist, Beckhoff, ABB, Siemens, Rockwell, just to name a few, and then ECEgraph. So there's some there. When we say ECEgraph, it could be multiple vendors using ECEgraph and CodeAssist as an example. So the solution is software as a service. So it is cloud-based, and you're going to use your browser, your favorite browser, to push the information up to the cloud. We do have a Control Expert plugin if you want to do some work that way. The server can either be both a public or private server. So today, if you don't tell us to do a private server, you would go to Schneider Electric server, upload your files to that. It would be processed. You could then download the information, utilize it in rebuilding your project. If the client wants to put it on a private server, meaning you don't want to put it up in the cloud, we have a way of doing that. It is a web-based platform for all 4 tools, and other services. We do allow integration with a COM server or version control type software. We have integration with that capability. So let's talk a little bit about each one of the 4 components. The control engineering verification. Like most web-based systems today, you're going to have a dashboard to tell you what's going on with the application that you've loaded in. It's going to help give you the results to help you understand where the application sits. In verification, we're going to run the application against a configurable rule set. Now, the generic rule set that we have is a collection of predefined rules from PLC Open. Rules can be customized to suit your company standard. And we can assist you with doing that. But the basic verification has a first set of rules. The benefit, we're going to run through the application, take a look at the application and compare it to the set of rules that have been defined. And we'll cover the set of rules in just a few moments. It is cloud or server based. You basically access it with a simple web browser user logon. So the converter main feature is converting from one version of PLC to another. So we can take it from a specific format, move it into another format. As an example, go from Rockwell over to Modicon M580. Covered in the conversion, automatic translation of the memory, the data types, the system libraries, the system information. There's no automatic translation due to the hardware. So we would figure out a way to attach the hardware back into the logic. Traditionally, what we've seen, it's faster than doing a manual rewrite. We take the application code and we recreate the code in, say, an M580, and then we reduce the risk. In other words, the code is converted and operates the same way. And re-engineering capability, you could do mass modifications during a conversion, such as renaming, adding comments, merging CPUs, modifying the language. We see a lot of times where customers want us to add additional documentation to a program that's been written 20, 30 years ago. The documentation side. How many times have you received a program with no documentation from the customer? They lost the documentation. You can go through the logic and it will go through the logic and figure out the control flow and data flow and allow you to easily figure out where everything is in the logic. So we go through it with built-in legacy systems. We understand a lot of those codes and support understanding of obsolete installed base. And of course, on the right-hand side, the control flow, the data flow, and cross-referencing it so I can look at an output and say, where in logic is that output impacted by other features, if you will. Again, cloud or server-based. Monitoring, we're going to take a look at the data flow and live monitoring. And on the screen that you have in front of you, it will in turn create a generic layout of what that logic looks like, whether it's Allen Bradley, whether it's Siemens, whether it's Modicon, so you can understand how the logic is flowing in the system. We can retrieve data from the PLC either via OPC UA or direct communication via Modbus TCP IP as an example. And the benefit of it, quickly understand the current state, and we have a uniform representation of the program no matter the PLC vendor or IEC language used. The tool integration, it's possible to integrate this tool with existing production tools such as SCADA, version management system, and communication servers. So what I'd like to do now is go back and go into the the verification tool, and then we can go back later on with anybody that would like it into the other tools. So in the verification tool, what you're going to do is you're going to get an application from a customer, or you're going to be creating an application, and the customer may have a certain set of rules for you that you have to follow. You turn it over to your various programmers, so you're going to have control over the delivered product, independence from suppliers. So you're looking at, are you doing all your programming in-house, or have you contracted programmers? You're going to certify the programming that it meets the certifying body's requirements, meaning the end customer is giving you a set of rules. It's going to allow you to create more robust code, and you're not going to have to go back into that code. Let's say when the customer comes in to do the factory acceptance test, as an example. So EcoStruxure control engineering, we can do better control sourcing, and this shows you how what we're using it for. Who is it for, and when do we use it? It can be used by OEMs, systems integrators, or end users. The end user could give you a set of rules that they want you to follow. Then after you write the application code, you could run your application code through this verification tool and say, I have met my customer's requirements. Or you could define your own set of rules that all of your programmers must follow on every program that they create. And this is a way for you to verify that program. So how does that happen? One, we're going to look for dead code. We're going to look for variable overlaps. We're going to look for variables that are written before a read that might cause a logic problem. We're going to correct program execution order. We're going to look at the naming convention that was created. Does every variable follow the naming convention? And then that's done by the verification tool. And then the other part of it is done by the model checking and factory acceptance tests. That's when you're going to verify that, hey, we're actually executing the code at the right time necessary for the application. So how does it work? You're going to bring your application in. It's a 5-step wizard where you upload the program, you choose the rule set, and then it applies the rule set to your program, and it creates a dashboard for you and lets you know how well does your application meet that set of rules. Each non-conformity found by EcoStruxure Control Expert is presented in the dashboard, and you can go through each one of those messages and answer them independently, or go in and say, hey, that rule, yes, we told you it needed to have a variable name of 10 characters long, but I'm going to okay this variable being 5 characters because the 5 characters clearly define what that variable does. It's useful for software developers. They want to improve their code and support a common set of rules. So the rule set, this is just a real quick overview of it. The rule set is the essential part. The customer can choose if they want to use an existing rule set. We do the PLC open, the GAMP5, or if you want to customize it and create your own. So as an example, on the right-hand side, there's a rule set for naming, comments, writing, and structured information. And the generic rule set is made up of around 40 best practices. And the rule sets tend to have 5 rule categories, as we talked about. And then you can define the severity. It's a fatal, it's error, it's a warning, it's information. Fatal does not mean the program's not going to run. It just means you've identified that rule that if we do not follow it, let's say the customer that's going to come in and go through the FAT test, he's going to redline your code, going to redline your drawings because let's say you didn't follow the exact naming convention for variable names. You can do a third-party audit. As the project matures, I can do the tool when we first start the project. Then the client might do a pilot project with it. Well, let's run the verification against a bunch of applications we currently have and see how well our legacy code meets our current set of rules that we need for documentation and everything. And then they will go in and define a standard use. So after they do the pilot project, they would go in and as integrators and as OEMs bring in equipment to the plant, the customer is now going to run a verification against your code against that set of rules that they may have given you. And before you even go to the FAT test, they will let you know if it's acceptable or not. In other words, what percentage of the rules did you abide by? So we get into that, and we also do version management. We can tie into that to a version management tool, and also can be integrated to a tool called SQUORE by Scoring Technologies, and that helps you do support reporting and decision making. Some of the tools that we can go into. So what I'd like to do, I'm going to step down and give you some ideas on where we have played with this tool. Remember, it is for OEM systems integrators and end users. These are some of the end users in the different markets that we have utilized the tool: automotive, energy, defense and space, and other energy, water, wastewater as an example. And here is a couple of customer examples. This particular customer is an aerospace company in France. Their challenge was the relationship. They wanted to improve the management between their relationship with their systems integrators. They wanted to enforce a set of corporate programming standards, and they wanted to verify the quality and safety requirements had been met. They chose EcoStruxure control engineering. They did a personalized set of rules based on their corporate standard. They did a project audit, 2 progress audits during development, and 1 conforming audit at end of development. So they're using that as part of their projects that they're going to deal with the systems integrators. The customer benefit: improved compliance, quicker and more efficient FAT testing, simplified maintenance. What does that mean to you as a systems integrator? Quicker and more efficient FAT testing. If you can get the FAT testing done quicker, you can ship the product and in turn get paid quicker by the company. Another example is a big automotive company in the United States. They have a large number of systems integrators and PLC programs from OEMs and SIs. They wanted, again, to enforce a corporate standard. They did a pilot project to test the potential of the tool. After that, they deployed it following a successful pilot project with a customized rule set, and then you can read the customer benefits there. These are the 2 that we have. As far as customer verifications, we can come up with some more. That concludes my presentation. And if you have any questions, please reach out to us. And we appreciate you coming to this presentation today and spending your time with us. Thank you.
Thank you both to Brian and Robert. And we have now the opportunity to ask questions to the presenters. When we started the presentation, I made myself a note to ask you about compatibility, connecting devices from other vendors. And in your presentations, you answered the question. It was quite impressive, the list of other vendors that you can configure. So that I was answering my own question just by paying attention to your presentation.
Okay. And I forgot to mention, just like Brian did, this is available on the Schneider Electric Exchange. You can go there and gather all the information on it. And if we can assist you in any way, or if you would like to get an example of your specific project that you have in mind, please let us know.
Okay, I think you did a great presentation because we have very few questions. So let's close it for today. Let me get to the presentation. So I want to thank you again, Brian and Robert, for this presentation. And I also would like to thank Schneider Electric for sponsoring this event. And of course, thanking all of you who attended the event. I would like to remind you that a recording will be available for viewing within the next couple of days. Be sure to bookmark the CSIA events coming. We have weekly events, so remember that. It's a great opportunity to stay current, especially during these times where trade shows are not so easily available. If you have more need for information from CSIA, here is how you can reach us. And we welcome your membership to all of those who are not members today. So thank you very much, and I wish you all a happy day. Goodbye.